4-2 trig functions on the unit circle. When doing a unit circle, you will have a circle with a radius of 1 centimeter, or 1 inch, or 1 unit, doesn't matter. But when you have that, every single spot on the outside of the circle will have some type of x and y coordinate. On a unit circle, sine function is simply described as the y value, cosine is the x value, and tangent is the y over x value at that point. Then so are their reciprocals. Cosecant, which is the reciprocal of sine, is 1 over y. Secant, which is the reciprocal of cosine, is 1 over x. And cotangent, which is the reciprocal of tangent, is x over y. So given any point whatsoever, you can find all 6 trig functions. Sine is equal to the y value. That would be square root 3 over 2. Cosine is equal to the x value, negative 1/2. Tangent is equal to the y over the x. So that's square root of 3 over 2 divided by negative 1/2. Well, we don't divide fractions. Instead, we multiply by the reciprocal, so you get square root 3 over 2 times negative 2 over 1 instead. The 2's cancel out. Final answer equals negative square root 3. Now, if you have the originals, you also have their reciprocals. The reciprocal of sine, cosecant, CSC, equals, flip it, 2 over square root 3, which turns into 2 square root 3 over 3. Cosine, reciprocal, SEC, reciprocal, negative 2. Reciprocal of tangent, cotangent. And the reciprocal would be negative 1 over square root 3, which turns into square root 3 over 1, negative. Every single point can come out into 6 trig functions every time. Using the chart, the circle chart that I've given you guys, you can come up with any one of these that you want and look them up, any XY coordinates. But you first have to figure out where you land. 11 over 2 pi's. Change it to a mixed number first. Then you have to go around the circle 5.5 times. So let's start. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and a half. And we finally end up at 3 pi over 2. And the coordinate points at 3 pi over 2 are 0 and negative 1. So from there, you have all 6 functions. Sine is equal to y value, negative 1. Cosine is equal to the x value, 0. Tangent is equal to y over x, negative 1 over 0. That's undefined. Cosecant, reciprocal of sine, equals negative 1 over 1, which is still negative 1. Cosine, which is secant, would be reciprocal, would be 1 over 0, which is undefined. And then cotangent, reciprocal, would be 0 over negative 1, which is 0. One thing you should pay attention for reciprocals, when you have 0 and undefined, they're reciprocals of each other. Find all 6 trig functions using no calculator for 720 degrees. So find all 6 trig functions, no calculator for 720 degrees. So the first thing you have to do is figure out where you land around your circle. So, as you know, one rotation around is 360 degrees. So if we take 720 minus 360, we end up with 360 again. So that's a second time around. So we end up back here. So at that coordinate, your coordinate points are 1, 0. So find all 6 again. So sine is the y value, which is 0. Cosine is the x value, which is 1. Tangent is y over x, that's 0 over 1, which is 0. Cosecant, CSC, reciprocal, that would be 1 over 0, which is undefined. Cosine is secant, reciprocal would be 1 over 1, which is still 1. And cotangent, the reciprocal would be 1 over 0, which is undefined. Again, given any point on that unit circle, any x and y coordinate, you can come up with all 6 trig functions. So, next example, 13 pi over 6, which comes out to be 6 goes into 13, that gives us 2 1/6 of a pi. So traveling around our circle, let's see where we end up. We go all the way around 2 1/6 more. So here we are, right there, at pi over 6. And the coordinates for pi over 6, square root 3 over 2, comma, 1/2. So find all 6 trig functions. Sine, square root 3 over 2. Cosine, 1/2. Tangent, you got to divide again. Square root, sorry about that, messed it up, hang on. 1/2 divided by square root 3 over 2, which changed to 1/2 times what? So, because it's y over x. So we've got 2 over square root 3, which equals 1 over the square root of 3, which converts to square root 3 over 3. Let's find the other 3. Reciprocal sine, cosecant. Take the reciprocal. You end up with 2 on top, square root 3 on the bottom, which then transfers to 2 square root 3 over 3. Cosine, its reciprocal is secant. The reciprocal would be just 2. And for cotangent, take the reciprocal of the original, which is just square root 3. All done. Now, using this information and using your chart and looking up specific ones, you can find any expression you want. So in the next example, sine of 90 degrees. So really, you want the y value at 90. So at 90 degrees, the y value is 1. For tangent of 45, at 45 degrees, you want y over x. So that's a square root 2 over 2 divided by the square root 2 over 2. And add them. Anything over itself is 1. So 1 plus 1, final answer, 2. All done. For the next one, this says to take 2 times the sine of pi over 3. So what is the y value at pi over 3? So look at pi over 3. The y value is square root 3 over 2. Minus 3 times the sine. We want the y value again, but this time at 270, and at 270 it's -1. So now we end up with 2 takes out 2, so square root 3 plus 3. Done. So this one, we're going to use our calculator to do these, okay? This is nothing more than typing them on your calculator and come up with the exact answer. So you're going to type in the sine of 28 degrees on your calculator and get a precise, neat answer, nothing else. Please make sure you're in degree mode for these two. Degree mode. But for this one, you have to be in radian. So using your calculator in degree mode, just simply type in sine of 28 and get an answer. 0.4695. Secant, however, is really the reciprocal of 1 over cosine 21. That's what you got to type in for that one. So we type in 1 divided by the cosine of 21 degrees. And we get 1.0711. Cotangent is really the reciprocal of 1 over tangent of pi over 12. But remember to change your mode to radians to do it before you begin. 1 divided by tangent of pi, put in your pi, divided by 12. Close it off, get an answer. Done. Using a calculator, nice and simple. Even in odd trig functions, okay? This is kind of cool about these because certain ones do certain things. Cosine and secant are even, so that means they're symmetric with the x-axis. In this case, when you have a negative on the inside, it just disappears. The negative sign just disappears. For sine, and cosecant, and then tangent and cotangent, they all have odd symmetry with the origin, so they reflect about the origin. And on this case, the negative sign pulls out front. Pull out front. So if I give you, for example, I want the cosine of negative 30 degrees. Well, that's nothing more than the cosine of 30 degrees on your calculator. You look it up, you got an answer. Go to your calculator, make sure you're in mode, in degree mode though, first. So you just type in the cosine of 30 degrees. 0.8660. If I wanted, for example, the CSC of negative 45 degrees. That's like looking up a negative CSC of 45. But CSC you can't look up, so that's really a negative of 1 over the sine of 45 is what you type in. So you type in negative 1 divided by the sine of 45 degrees. And you get negative 1.4142. All done. Thanks.